To build our catcher game, the first thing that we need to do is go into our timer class and modify one little thing, because the timer class has a method called complete, and that is expecting something to be returned. And as you can see, the current function is stubbed out empty. So we will just simply put in a basic return true statement, and then that's going to prevent any issues. Now that I've done that, the next thing I want to do is set up the size of my project, and I will go for the default 800 by 600 because that's a convenient size. Looking at the program, the catcher is going to be our first item that we are going to work on solving. The first thing I want to do is to talk about the radius. The radius is half of the width of the object. The catcher is going to be a circle or an ellipse. So it's going to have a radius. And that's important because we are using circle-based collision detection in this program. And as we do that, we need to set up a radius value or a half width value for each of our objects so that we can determine when those two objects have gotten too close to each other and are indeed overlapping. So we will set the radius equal to the temp radius value. This is going to be a number that is passed in when we call this constructor method. That allows us to modify the size and value of it as we are working on our program. Next, we want to set up the x and y of our objects. So we'll say x is equal to the width, or to, actually we don't need to set up the x and y of our object here. So the next item is to set up our x and y values. So we'll set our x equal to the width of the screen divided by 2. The y is going to be set equal to the height of the screen divided by 2 as we put those values in. Moving into the update function, this is where we're going to set x equal to the mouse x. So wherever the mouse moves, the catcher object is going to move, and then we'll set the y there as well. And finally, we need to draw this. Because we don't want this to have a stroke on it, we're going to set its value equal to no stroke, and then we'll set our fill value to be a medium light gray of 175. And then I will draw my ellipse at x, y, and r times 2, remembering that the radius value is half of the width or height of it. And ellipses are looking for a width and height value, so we just take that and multiply it by 2. Auto format so it cleans up the presentation of the catcher. To implement the catcher into the project, now we can see we've created the variable to hold a reference to it. Now we're going to call the catcher's constructor. So we say catcher is equal to new catcher. The instance variable name is lowercase, referencing the class name. We use an uppercase value. Now we just tell the catcher to update and tell the catcher to display. And if I run my project, when I run the project, I'll see that it's giving me an error because it says the constructor doesn't exist, because I called a constructor that has no values in here, no temp radius being passed in. So I need to pass in a value. I'll pass in a value of 16, giving me a catcher 32 pixels wide. Now when I run it, it's happy. We can see it works, but oh, look, I forgot to clear the background. Stubbed out the function, but haven't put it in yet. So I'm going to set my fill color to 255 or white, and then I will draw a rect from 0, 0 to width, height. That will flood the screen with a box. And now if we run it, we'll see, again, same value, because, well, I've populated it. I need to also remember to clear the background each time I wish to use it. And now, when I do this, we will see that object is moving around correctly on screen. The next thing that I want to do is to work on my drop object. To work on the drop object, it's another visual object similar to what we've had before. And as we look at this, we'll give it a R value of 8, and we're going to give it an X value of random with, so it appears somewhere on screen. My Y is going to be set to a negative R times 4, so that guarantees it appears somewhere above and off of screen. We don't want it appearing on screen. My speed Y is going to be set to a random value of 1 to 5, and my color for the object is going to be a blue, blue, green. So I am going to set its color as I fit the color onto the screen. Let's go with 50, 100, and then we'll have a random value. So there's some variation within this of 100 to 255. So it's going to be blue, the hint of green as it factors in, but mostly in the blue family for colors. Now that we've set the base values with this, we need to update our position. And as we do that, it's going to be y plus equals speed y, similar to what we've done before. And then we'll check our bounds and do a simple if y is greater than height, which, remembering we're starting off screen up top where we're less than 0. Now we're going to move to a position greater than the overall height of our screen. And if we're all the way off, that would be our height plus our radius value. Return twice, close out the curly, up arrow once, and then y is equal to -r. Now to move on to display, as we go to set this into the project, then we can say no stroke again, and then set our fill color to C, and then draw ellipse at x, y, r times 2, r times 2. So remembering that we're using the same kind of logic and method that we used with the catcher object. Now that I have the drop class started, we'll worry about caught and reset in a little bit. The next thing that I want to do here is to add in a drop. So we can see that we have the drop array existing, waiting for us to populate that with a bunch of drops. Number of drops is waiting there as well. We haven't defined that. So the number of drops is how many drops we want to appear in our project. So I'm going to set number of drops equal to 100 in the beginning. The advantage of referencing it through a variable is I change that number here, and it will modify how the rest of my code works without breaking it. Otherwise, if I hard-coded in the number 100, as we would see here, where I'd say drops is equal to new drop, and to find out my array, if I hard-coded the number in here every time I did the loop, it was hard-coded, that'd just be a mess. If I just have a value, number of drops, that I can change, then I can update my program, go from 10 drops to 1,000 drops without blinking an eye. I'm just changing one single number. So now we reference number of drops. So that now creates the values to go into the array, and now we need to populate that. So we use a simple for loop. Int I is equal to 0. I is less than number of drops. And I plus plus. Return twice, curly, up arrow, and now we can say drops and use our array notation of square brackets, and then we're saying which index position. And we'll say that drop is equal to a new drop, like this. So that now populates that with the new drops. The next thing we need to do is to run update and display on all those drops, and we'll get to see our drops appear on screen. So to do that, we can just grab this, and then we'll modify it a little bit here. Instead of creating a new drop, we just tell that drop to update, and then drops square bracket I dot display. And now that I have done that, I can run my program, and we'll see all the drops start falling. Key thing to notice here, all the drops are pretty much falling at once. We'll temporarily set their speed to the same value so we can see that happening. And as I do that, we will see that now they fall in a single line. So that doesn't really help. But do notice that we have the asteroids effect going on here, that they're screen wrapping. They get to the bottom, then they go back and start at the top. So that's kind of cool the way that's working. So it tells me that the next thing I want to do is to figure out how to include the timer in my project so that I can control the release of my drops so it only does one at a time. With the drops falling, the catcher moving, we want to control the release of the drops. We'll do that through our timer class. Now the timer class, the way that it works is the timer we tell it to start, and we keep asking it every frame, are you done yet, are you done yet? And when it's done, it will return true with the complete function. So we say, are you complete, are you complete, are you complete? To do that, we need to set up a couple things. We'll set our interval equal to the time interval that we passed in when we called the constructor for the timer. And the next item I want to do is set my start time equal to, and this time we're going to use a value called millis. Now millis, when we call this, it will return a value and tell me how many milliseconds, thousandths of a second, that my program has been running. So all of our units of time are measured in 1,000ths of a second. So 1,000 milliseconds is 1 second of time. So when I call start, it's going to set start time equal to whatever the current millis are, however many milliseconds the program has been running. Because it really doesn't matter. We don't need to start from 0 or anything like that. Because then we're going to set a a local variable to this function, and we'll call it elapsed time. And we'll set elapsed time equal to now the current, because every time I call millis, it gives me what is the absolute most current time since this was called, since the program started running. So every time I call it, I will get a new value. So now I am going to subtract millis from my start time. That's my elapsed time. And I will say if elapsed time is greater than my interval, which is how long I want my timer to run, and I established that when I constructed the timer, then I'm going to return true. Now I'll close out my curly and say else, meaning elapsed time is not greater than the interval, and now we want to return false. Close out my curly, get rid of this previous line here. We don't need it anymore. And that completes the timer function. We really don't need to go back and visit this anymore. So that completes our timer class, and we really don't have to go back and visit it again. Just remember, we create an instance of the timer and we say what interval we want the timer to run on, and then we will keep asking the timer, are you complete, after we've told the timer to start. And once it's complete, it will send back a return value. Once it's done that, if we want to click the timer to run again, then we just tell the timer to start, and the process starts all over, and then we keep checking, asking, are you complete? And once it returns true, then we do something else. And that's what we're going to figure out how to do in the game. So to do this, now we need to add the timer to the project. To add the timer to the project, we're going to create a reference to a timer instance of the timer class. So we'll say timer. We need 2 more values. We need our time interval, and this is how frequently the timer is going to run. And then we need a value which is how many drops are currently active. Now as we go through the project here and are going to work with that, now we're going to set up our timer stuff down here, and I'll say timer is equal to new timer, and now I need to pass in a value of how frequently I want the timer to run. If I pass in a value of 500, that says every half second or 500 milliseconds I want my timer interval to fire that it is complete. The next thing that we are going to do here is, I just said I want my time interval to be 500, and what did I forget to do here? I forgot to say time interval is equal to, we're going to make our drops fall fast in the interest of we want to see something happen. Or actually we'll keep it slow in the beginning so it's more apparent that something is happening. And now we have our time interval, which I have to spell it correctly up here so all my values match. Time interval is now 500. My timer will now be a new timer element with the time interval of half a second. And now we can tell the timer to start. Once we tell the timer to start, then inside of our draw, this is where we are going to work with it. Now we do need to also do one more thing. As we set the time interval, we probably should set our active drops. equal to 0. I could have got away with that in processing because processing is not going to be that concerned. If I don't give something a value, it assumes I wanted a value of 0, but the proper way to do it is to make sure I have assigned values to everything that I'm working with. Now, what I want to do before I start telling my drops to do something, I want to work on my timer stuff. And with this, I'll say if timer is complete. So I'm asking, does the timer complete method return a value of true? And if it does, then we have to ask a second question of if my number of active drops is less than my number of drops, then at that point, what we can do is we can make active drops increase by 1. When we look at this, it's not going to appear to be doing anything crazy or wild, but what happens is active drops started at 0. When the timer is done, then if active drops is still less than number of drops, 0 is less than 500 or 100, then active drops becomes 1. What we want to do is instead of telling all of our drops to display, we're only going to tell the active drops to display. So our loop, we're changing this here. This is now drop stuff. And we're taking that drop stuff and we're changing it. So we change it from number of drops to active drops. So we only want the current active drops to keep falling, or to start falling. If I run this, we'll see it starts very quickly. What we also need to do while we're increasing the number of active drops, we need to then tell the timer to start over. Because if we don't do that, half a second, the first one fires off, and then it acquires 60 drops per second more because we do 60 frames per second. So then it pretty much, within a second and a half, active drops had maxed out at the number of drops. But now if we start the timer, it's only going to update when timer is complete. So if I run it once more, we'll see 1 drop, 2. So we can see how it's a much more controlled dropping experience, so we don't get that massive monsoon deluge of drops falling down on the screen. The final step that we need to do in our catcher game is to add in some scoring so we have some visual feedback. So to do that, we need a way to keep track of the score. So we will create a variable of type integer and refer to that as score. The next item that we want to do is to have a string. We'll just call it S. That string is something that we will use for populating our score text field. So while we're keeping track of score, we also need to be able to show the score to the player on screen. Now to populate those values, we'll set our score initially to 0, and we will set S equal to a string, and we'll say score colon space, close out our with the quotation marks, so now we have that string, and then we will add to it the variable score, so then it will put that number. So if I were to show this text on screen, it would say score colon space and 0. Now as we look at it and look through the code and try to figure out where it makes sense to add this in, whenever a drop is caught, that would be an appropriate time to add to our scores. So after we catch a drop, we can simply say score plus plus. Finally, we need to update the UI on the screen. And to update the UI on the screen, we have to set some text properties. So we will set text size equal to 12. That's a pixel measurement. Then I will set my text align and align it to the left. Then we'll set a color. I'll just do 255, 0, 0. So we're filling our text with a red color. We'll now set S equal to the same thing we did before, score colon space plus score. Now, recognizing that, we may realize that perhaps we could recycle that or write a function because we've now duplicated the same line of code twice in our program, but for now we're going to leave it as is. Finally, to get the text to show up on screen, we use the text command. We specify the string we want to see, and then we specify a location, an x and y value of where we want that text to show up. If I run my program, we'll see the drops fall, and as I catch those drops, my score starts going up. So with that, we've completed the first stage of the catcher game, and next we will figure out how to add in game states so that we can win and lose and restart the game after that happens.